And this is widely used formula. So once we prove it, it will be easier for you to remember. Okay, let me start with saying that I cannot use tangent alpha plus tangent beta. There is a formula for that, but I cannot use it because tangent alpha plus half a pi. I cannot use it because tangent half a pi is equal infinity. Okay, so this is half a pi. This is negative half a pi. If you open the graph of tangent cotangent, I have special video for that. You will see, and the graph is going like this, and half a pi is a vertical asymptote. So at the point of half a pi, it's equal infinity. Therefore, we cannot use this formula, apply formula tangent alpha plus beta when beta is equal half a pi or alpha is equal half a pi. Okay, so we will go different way. By identity definition, tangent alpha, right, is equal sine alpha over cosine alpha, and this is what we will use. So instead of a tangent the alpha plus half a pi, we will use sine alpha plus half a pi divided by cosine alpha plus half a pi. Okay, and what do we have that gets? Now I can open sine alpha plus beta, cosine alpha plus beta, right? So sine alpha plus beta is equal sine alpha cosine beta plus cosine alpha sine beta, and the opposite, cosine alpha plus beta is equal cosine alpha cosine beta minus sine alpha sine beta. Okay, let's apply. So we have, since I'm going to prove that tangent alpha plus half a pi equal negative cotangent alpha, I'm going to do changes to tangent alpha plus half a pi and bring it to negative cotangent alpha. So sine alpha plus half a pi, it is going to be sine alpha cosine half a pi plus cosine alpha sine half a pi. Okay, divided by cosine alpha cosine half a pi minus sine alpha sine half a pi. So what do we get? We are getting cosine half a pi is 0, right? Here also cosine half a pi is 0, and we are getting 0 plus cosine alpha, and sine half a pi, by the way, is 1. Sine half a pi is 1. So as a result, we are getting cosine alpha divided by negative sine alpha, which is equal negative cotangent alpha, okay, which we proved. So we got negative cotangent with the changes, and tangent alpha plus half a pi we brought to negative cotangent alpha. Okay, that was first one. Moving to second one, I would think I would put this proof here as a common because we are going to prove some more. Okay. Next, number 2, we are going to prove that 1 plus cosine negative 1 degree to alpha plus tangent to alpha multiplied by 1 minus cosine to power negative 1 to alpha and plus tangent to alpha, and that's all is equal to tangent to alpha. Okay, so the left part of equation we are going to simplify, bring to the right part of equation. Okay, let's start working. So the left part we are going to simplify. First of all, it's gonna get 1 plus 1 over cosine to alpha, right? Degree negative 1, meaning 1 over. And plus tangent to alpha is equal sine to alpha over cosine to alpha, yes? Because tangent is equal sine by cosine. Next, 1 minus 1 over cosine to alpha plus sine to alpha over cosine to alpha. All right, next, what we are going to do, bring to common denominator cosine to alpha. So 1 will become cosine to alpha plus 1 plus sine to alpha. Okay, and this is multiplied by cosine to alpha. Here we get cosine to alpha minus 1 plus sine to alpha. Okay, next, when we multiply, we are going to get cosine squared to alpha, right, in the denominator, because cosine to alpha times cosine to alpha, we get cosine squared to alpha. Now, what do we have here? Look at that. I can write down here, let me see. Look in which format I'm going, not format, actually, yeah, format. Cosine to alpha plus sine alpha plus 1. And here I have cosine to alpha plus sine to alpha. Oops, here also to alpha, I'm sorry. Sine to alpha and minus 1. Look at that. I get A plus B, A minus B. Yes? And the result is going to be A squared minus B squared. Yes? Which is going to be A squared, it's going to be cosine to alpha plus sine to alpha squared and minus 1 squared, which is 1, obviously. So let's see how much we will get here. All right, this is equal. So we need to open the formula cosine to alpha plus sine to alpha squared. It's like a plus b squared, which is a squared plus 2ab plus b squared, right? Okay. Okay, a plus b squared is equal a squared plus 2ab plus b squared, right? Okay, let's do it. So if we square it, we are getting cosine squared to alpha plus twice sine to alpha, cosine to alpha, and plus sine square to alpha and minus 1, because 1 squared is 1 over cosine squared to alpha. From here, we are going to get cosine squared to alpha plus sine squared to alpha. That's going to be equal 1. There is a formula. Sine squared plus cosine squared is equal 1. So we are getting 1 plus 2 sine to alpha, cosine to alpha, and minus 1 divided by cosine squared to alpha. Okay. We are getting 2 sine to alpha divided by cosine to alpha, right? Because this cosine to alpha is gone with this square. Let me use different color so you would see this with this, okay? And the answer is 2 tangent to alpha. Let's come here and see if that's what we needed to prove. That's exactly what we needed to prove to get to tangent to alpha. Here we got to tangent to alpha. All right? Okay. Moving to next proof, number 3. Again, we need to prove cosine to power negative 1 to alpha plus cotangent (5 over 2 pi plus 2 alpha multiplied by cotangent 5 over 4 pi minus alpha is equal 1. Okay, we need to prove that the entire this left side is equal 1. Well, let's start. Cosine to negative 1 is 1 over cosine to alpha, right? Plus cotangent. Okay, cotangent and tangent, you see me writing down different ways. Sometimes tangent, x, and tangent. It's both of them means tangent. One is European, one is American, so I use both of them. Cotangent and cotangent. Okay, so either way it's fine. So plus cotangent. So what am I going to do? 5 over 2, I'm going to break down 4 pi plus pi. Why? Because 5 over 2, I can't do anything. I need to get period out, and period for cotangent is 1 pi. So I'm going to put 4 pi plus 1 pi divided by 2 and plus here 2 alpha, right? And that's all multiplied by cotangent. Same thing here. It's going to be 5 pi, 4 pi plus pi, right? And that is divided by 4 and minus alpha. So the result is we are getting 1 over cosine 2 alpha plus cotangent. So 4 pi plus half a pi, right here. 4 pi over 2 plus pi over 2, right? If I divide by 2, each one of them. So 4 pi over 2, it's going to be 2 pi. So we are getting 2 pi plus pi over 2 plus 2 alpha. Why did I separate them? Because I want 2 pi take out. It's twice the period of cotangent and tangent. Period of tangent, cotangent is 1 pi. So if I get 2 pi, I still gonna get the same pi, half a pi plus 2 alpha. Whoever hasn't learned how the function sine, cosine, tangent, cotangent behave, it will be maybe confusing what I'm writing here. So, and all this I'm multiplying by cotangent. So here is also, it's going to be 4 pi over 4 plus pi over 4. Yes? And as a result, we get pi plus pi over 4 minus alpha. Okay. Next. Look here, I have everywhere cotangent, and all of a sudden I have here cosine to alpha. Therefore, and because there is a formula that convert cosine alpha to sine to tangent, I'm going to use that formula. This formula is, okay, cosine alpha is equal 1 minus tangent squared alpha half divided by 1 plus tangent squared alpha half. Okay? So, what do we have? Cosine to alpha, I'm going to break down 1 over 1 minus tangent squared alpha 1 plus tangent squared alpha and plus cotangent. Since period is 1 pi, so even if we go 2 pi, you're still going to come to the same angle, half a pi plus 2 alpha. Therefore, since position is going to be the same, therefore, it's going to be equal cotangent half a pi plus 2 alpha. Because you will end up, if you add, just like same way, like let's say this is your circle, right? It's in this position. period is 2 pi, which is 360. You come 360 and you end up in the same position. The same way with cotangent. Period is 1 pi. So since you have 2 pi, so you just go twice. If you go twice, you still end up in the same position, right? So actually it doesn't matter how many times you go. As long as it's times pi, then you will end up in the same position. Okay, times, same thing here, you pi plus. So you will end up in the same position of pi over 4 minus alpha. Okay, so 1 divided by 1 minus tangent squared and 1 plus tangent squared. It's going to flip, and we're going to get 1 plus tangent square alpha over 1 minus tangent square alpha. Okay, plus cotangent half a pi to alpha one second times cotangent pi over 4 minus alpha. Okay, so from here we are going to get, cotangent pi over 2 plus 2 alpha. Previously we proved, right, that tangent, where is it? First one here. Tangent alpha plus half a pi equal negative cotangent alpha. Let me write down. Plus half a pi equal negative cotangent alpha. Therefore here, in this case, we are going to get 1 plus tangent squared alpha, 1 minus tangent squared alpha, and cotangent half a pi plus 2 alpha. It's going to be negative tangent because cotangent, one second, because cotangent alpha is equal 1 over tangent alpha. From here, it's going to be the minus tangent to alpha. Okay? Oh. We take in parentheses. Okay, since I have here everywhere I have tangent, I might as well want to convert cotangent into tangent using this formula, right? And I will get 1 over tangent pi over 4 minus alpha. And from here, I have, so 1 plus tangent squared alpha over 1 minus tangent squared alpha, and tangent to alpha, I'm going to use the formula where tangent alpha is equal to tangent alpha half divided by 1 minus tangent squared alpha half. So since I have tangent to alpha, it's going to be minus 2 tangent alpha divided by 1 minus tangent squared alpha. Okay? And that is multiplied by So what is the formula for tangent pi over 4 minus alpha? So here is the formula. Tangent alpha minus beta is equal tangent alpha minus tangent beta and divided by 1 plus tangent alpha and tangent beta. Since I have 1 over divided by tangent pi over 4 minus alpha, so if I plug this formula, formula here, and 1 over this fraction is going to flip, and I will have 1 plus, right, tangent pi over 4 tangent alpha, and in denominator I will get tangent pi over 4 minus tangent alpha. Okay, so tangent pi over 4 is equal 1. Why? Because tangent we said is equal as tangent alpha equals sine alpha over cosine alpha. Pi over 4 is 45 degrees. For 45 degrees, since sine is equal to cosine and it's equal square root over 2, square root 2 over 2, so it's equal 1. The same thing is here. It's 1. Okay? And as a result, we are going to get, let me see what we can do here in parentheses. Bring to common denominator, which we have. Just combine together numerator. 1 plus tangent squared alpha minus 2 tangent alpha. Okay, and that's multiplied by 1 plus tangent alpha and divided by 1 minus tangent alpha. Okay, so from here, what is it going to be? Let's do drafting. 1 plus, okay, I'll do drafting here so not mix up with formulas. So 1 plus tangent square alpha minus 2 tangent alpha. I can write down in this format 1 minus 2 tangent alpha and plus tangent squared alpha. So this is going to be 1 minus tangent alpha squared, right? This is will be a squared, this is b squared, and this is minus 2ab. Okay, so from here we are going to have 1 minus tangent alpha squared over, and 1 minus tangent square alpha in denominator lets me do drafting here also. 1 minus tangent square alpha, it's like a squared minus b squared, right? I can put here square, and that will be equal 1 minus tangent alpha and 1 plus tangent alpha. So that will be 1 minus tangent alpha. Wait, let me write down properly. Tangent alpha, 1 plus tangent alpha, and multiply by 1 plus tangent alpha over 1 minus tangent alpha. Okay, so what do we get from here, from this multiplication? Let's see, 1 minus tangent alpha is gone with this square, and then 1 minus tangent alpha is gone with this one, and tangent alpha, 1 plus tangent alpha is gone cancel with 1 plus tangent alpha. And as a result, we are getting equal 1. Finally, we reached the verdict. Okay, and we had to prove that it is equal 1. Here we have, okay, and we did prove it's equal 1. Okay, I think it's enough to digest, to understand. So I would recommend after you watch the video, write out these equations and prove themselves the identity that all this expression on the left side equal to the answer on the right side. And I'll see you next time.